Look at lesson 12.2 now. If you need this, if you want to pull up my calculators from Desmos, just go ahead and take a scan at that. Alright, so what we're going to look at today is evaluating limits of polynomial and rational functions, not only at selected points, but also at infinity. And so the terms you might hear today are direct substitution and indeterminate form. Actually, you probably won't hear me say that very often, but you will hear direct substitution quite a few times. So some limits of functions rules, as we've learned that if we're looking as x approaches this value c here, so as we approach c, that means you're looking at it as the graph itself approaches it from the left side and the right side. And if as long as it's the same value, we'd get the value k. And this is saying if you have a constant function, then the limit of x approaches c of k will be equal to that k. So if that's the y value, that's what it'll be equal to. And another one is also an identity function. If you're looking at the y equals x line, the line y equals x, or f of x equals x, if you're saying what's the limit as we approach this value c, well, the answer will be c, because the identity means the y is equal to the x. So if x is c, y will also be c. Now, here are the rules that, as I mentioned on the bell ringer, I'm going to leave up on this page. So if you remember, I went to our lesson instructions and I opened up the digital copy. You could also click the completed copy if you like. And I'm going to look for this particular slide, the property of limits, to keep that open as we go through today. So here's the property of limits, and I'm going to just zoom in on this a little bit, maybe even a little bit more, so we can see our properties as we go through today. So the whole idea today is, without using a calculator, to graph like we did last class, how could we find the limit of this function? So looking on this, the graph, we would have said, okay, as we approach 3 from both the left side and the right side, it approaches the y value of 11. That's how we would have done this on lesson 12.1. Well, how can you do it on 12.2? Well, using these properties, first we could say that this right here would be equal to the limit of x approaching 3 of x squared plus the limit as x approaches 3 of 2x minus the limit of x approaching 3 of 4. Now notice I just kind of like distributed that limit through there, if you will. I put the minus on this side. You could have said plus a negative 4. It doesn't really matter. But I kind of distributed it through. Now that is using the sum property. So the property of functions or multiple functions being added together, you could separate and do limits of each individual function and add those value up. That's what I did right there. That is the sum property. The sum property. Now, as you look on, you will see that there's properties for if you have a power. So here's the power property, and it just says, hey, if you have a power, you can take the power of the entire limit. So using the power property, we could say this will be equal to the limit the identity function as x approaches 3, and then just square this. That right there is what we call the power property. I'm just going to write power property. And then over here I have a limit of 2x. This is the scalar property. It says if you're multiplying a function, you can just move the scalar to the front. So I'll say this is the same thing as 2 times the limit as x approaches 3 of the identity function. That right there is the scalar multiple property, scalar multiple property. And then we finally have over on this side just that constant. If you remember from the previous slide, it's just a constant. And so that just means that the limit, no matter what the number is here, c, if it's a constant function, will be a number here. So here I'm just going to, that was the limits of constant functions is what they call that. And so I'm just going to put minus 4. That's the limit of constant function. Limit of constant is what I'm going to write. Limit of constant. And so we just get the value 4 there. Constant. Okay. So now how do I evaluate this? Well, this right here is the identity function, which means that value is going to simply be 3 squared, because that's the limit of an identity function. Limit of identity function is just the number itself. So if x is approaching 3, that's a 3. So it'll be 3 squared. And put that squared more on the 3. Plus here, again, this is identity function. So it'll be 2 times 3 here. minus 4. And so those are both the limits of an identity function. So now I can just simplify the math. 3 squared is 9, plus 6, that's 15, minus 4 equals 11. And that is my limit right there. My limit as x approaches 3 of x squared plus 2x minus 4 would then equal 11 using those properties. And so you saw it here graphically and now doing algebra here. Here's part B. So it says use the properties of limits to evaluate this. And so I'm going to walk you through the same limits. So there is a quotient property, and I'm going to use that one first. It says the limit as x approaches negative 1 of 2x, there it goes, squared, minus 3. And the quotient property says is you would just separate it and have each limit individually. So I can take this limit and divide it up each individually. This is the quotient property. And now what I could do is separate these just like we did before. We could do the sum property of 2x squared. I'm going to make that a minus the limit as x approaches negative 1 of, I took the minus already right here, so I'm just going to do a 3. All this over, that's the sum property, and I'll do the sum property down here as well. Okay, I'm going to put these in parentheses because that x and the plus look kind of strange to me. Let me put that in parentheses like that. Okay, so now I've used the sum property to distribute those out even a little bit further to separate them, simplify them. We could continue on this next one. I'm going to do true properties in 1. I'm going to change this right here to the limit as x approaches negative 1, and I'm going to put the 2 in the front. That's the scalar multiple property, and I'm also going to the x itself is squared. So it's not the 2 that's squared, just the x. I'm also going to square the limit itself, not the scalar, but the limit. And then I'll subtract this right here will become a 3. That's the constant function. Let me change colors, something I haven't used yet. This will be the scalar, constant. That's a limit of a constant. Over here, I forgot to write it. That was the scalar multiple. And the power property. And this will be divided by, over here, this is the identity function. So we'll have just a negative 1. That's the identity. A limit of an identity. What's the sign spell identity? I'm missing the, there we go. Limit of an identity plus 2, which would be a constant. So I'll color coordinate in here. And so now if I wanted to simplify this, I can go one more time. That identity function on the first limit will be that value is a negative 1, so it'll be 2 times negative 1 squared. That's identity. And then we'll subtract the 3 over, and I'm just going to simplify this. Negative 1 plus 2 is the same thing as 2 minus 1, which is 1. And so dividing anything by 1 doesn't change it. So it seems like to me that this value will end up being negative 1 squared, which is 1. 2 times 1 minus 3. Go ahead and put the equal sign right there. And 2 times 1 is 2 minus 3. I'm getting negative 1. So the limit of 2x squared minus 3 over x plus 2 as x approaches negative 1 will equal negative 1. And if you want to check this out by graph, you could. Let me clear off these. if I graphed 2x squared, make sure it's all dividing. Okay, 2x squared minus 3 over x plus 2. As we approach negative 1, you can see the y value that it's approaching is negative 1. As we approach from the right side and the left side, we approach negative 1. So we did, in fact, do that correctly. So let's try this one more time. Oops, let me get my properties back. Okay, and so now I have a root. And what this is saying is that you could say that this is equal to the square root of the limit as x approaches 2 of x plus 4. Now that right there is the nth root property. The nth root property gives us that. And now I can just keep using my properties from there. We have a sum property in there. So I could say the limit of x as x approaches 2 plus the limit as x approaches 2 of 4. And without just continuing to write the property names each time, I'll come back and do that in a second. This would be equal to, that right there will be 2, and this right here is 4. Identity, and that's a constant, which is going to equal the square root of 6. And so the answer here, since I cannot reduce the square root of 6, the limit as x approaches 2 of the square root of x plus 4 is going to equal the square root of 6. So now that I walked you through a few, you can go ahead and try this problem. Stop the video if you need to.